All right, in this video, we're going to be discussing Hamiltonian circuits. So let's go and get started. All right, so the best way to explain it is just to kind of use a real life example. So what we have here is basically a map of a city, and it says you work for UPS and you have deliveries at each vertex listed below. Can you find a route that goes through each vertex exactly once and gets back to UPS? All right, so let's just kind of bring reality into it. Okay, so let's forget about math and let's just bring reality. And so what I mean by that is, let's say if you work for UPS, all right, so here is where you're starting. All right, so this is where your truck will leave from. So what is the best way? Like, for example, you could go anywhere. So let's just say you go to Walmart. All right. Now, after I go to Walmart, I'm probably going to go to the next place that's closest to me. That'll make the most sense. And then from this point, I'm going to go the phone store and then the gas station, go to Kroger. And if you notice that I'm not using every edge, well, again, in reality, would you really drive over every single road that's available to you on a map? The answer is no. You'd go to one place and then you'd try your best not to backtrack anything. So Target, Zaxby's, and then the gym is my last stop, which means my last stop, my next stop is back home. All right. So notice what I did was I started from UPS. I was able to connect or go to all of the different stops and go back to UPS. All right. Notice I didn't use all the roads. I didn't have to use all the roads. All I needed to use is the roads that took me to each spot. So what I've just created, now let's bring the math back into it, is what is called a Hamiltonian circuit. And it's basically a route that starts and ends at the same vertex. So we started and ended at UPS. Each vertex must be connected only once. So basically what that means in this example is, like, once you go to Walmart, you don't go back to Walmart. Okay, so each vertex has to be touched exactly once. So, like, for example, once we went to the phone store, we kept going. We never went back to the phone store. And then not all the edges will be used. So again, going back to this real life example, you're not going to use every single road that's available to you. You're just going to use the roads that connect the dots, so to speak. All right. And lastly, there could be different routes. So if you notice, this is the way we went. We went UPS, Walmart, Home Depot, whatever. But you could have said, you know what, UPS, I want my first stop to be Archer. And then from Archer, go to Target, go to Zaxby's, go to the gym, swing this way, go to Walmart, Home Depot, boom, boom, and boom. That's another way. So there's more than one way to find a Hamiltonian circuit. All right. So let's kind of go into a couple of examples. All right. So can you find a Hamiltonian circuit in the following graphs? Remember, in this particular graph, you don't necessarily have to use every vertex. I'm sorry, use every edge. We've already talked about that. And then also, there's more than one answer. So you choose. So eeny, meeny, miny, A. I always like to start with A because it's just the first letter of the alphabet. So if I was at A and then I just went to B because I wanted to, you got to go somewhere. All right. So again, a lot of students get screwed up because of the fact that they think to themselves, well, there's got to be a special way. There's not a special way. It's basically trial and error. From B, you go to C, C to D, E, boom, there you go. That's one answer. I was able to start at A, I was able to finish at A, and I was able to connect the dots. All right. So let's say John, that was his answer in first period. But let's say little Susie said, you know what, I want to start at B, and then I want to swing this way, and then let's just say I wanted to go to E, okay, go to A, all right, D, and B. Is that the correct answer? Yes, it is. It's a different way, but it is another answer. So that's little Susie's answer. Well, let's look at Sally in third period, and we'll stop from here. Let's say Sally goes, you know what? I want to start with vertex D. All right. Starting at vertex D, I'm going to go to E. Okay. And I'm going to swing over to A, go to B, swing over to C, go back to D. Is that the correct answer? Yeah, that's the correct answer. It's just another way to connect them. So those are three different ways that you can get the same exact answer. All right. So now there's going to be sometimes I'm going to ask you as a student or as a teacher. Okay, what was the route you went? So in this answer, it would be D, E, A, B, C, and back to D. There you go. That's it. All right, looking at this next answer or next question here, can I find a way that connects everything and gets back to my starting point? Huh. This looks a little challenging. So let's start with J. There's a lot of ways to get back to J, so let's see if we can. All right, go in this direction. We're stopping at D. If we went to C, I cannot get back to J. So okay, that way's a no-go. Let's see, maybe starting with J wasn't the right way. Let's start with D. So D, okay. I think I'm gonna get stuck again. Oh, my mouse screwed up here. Let's try this again. If I swing it around, I see. All right, so I'm at F. If I go to J, I can't get back to E. So okay. All right, so in this case, I checked it. I could not find a Hamiltonian circuit. All right, so this would be a big fat no for this one. All right. All right, looking at the next one. This is another one of those delivery places. So let's see. The company's main warehouse is in Atlanta. Okay, so basically, we're trying to find a way from Atlanta to all these different cities back to Atlanta. Again, giving you a lot of freedom in this. So from Atlanta, you choose where you want to go. Okay, so let's say if I just wanted to go to Rome to Dalton to Athens to Augusta to Savannah to Valdosta, Americus, Columbus, Macon, back to Atlanta. Oh, there you go. Hamiltonian Circuit. Let's see if there's another way. All right, let's see. Let's say if we started with Atlanta and then I'm trying to look here. Maybe, let's say if we went to Augusta, Athens, Dalton, Rome, Columbus, Americus, Valdosta, Savannah, back to Macon, back to, oh, look at that. There's another way. Hamiltonian Circuit, folks. All right, so we're pretty much going to fast forward. I think you guys get pretty much the gist, and this is the easy concept here. All right, so the last thing I kind of want to talk about is something that looks like this with the digraph. Now, the thing about a digraph, very simply, is that you got to follow the arrow. So, like, for example, if you started with, let's say if you started with 2, look at all the arrows going to 2. The only way to leave 2 is to go to 4. You got to go with the arrow. So 2 to 4. And then let's see if we just went down to 3. Okay. Went to 5. There we go. From 5, we have options, but we can't go back to 2, so that's a no-go. We can't go to 6, that's against the arrow. So we have to go to 1. From 1, again, can't go back to 2 because we got to go to 6. Go down to 6 right here, like so, and then back to 2. All right. So very simply, what was the route I took? I went to 2, I went to 4. I think I went to 3, 5, 1, 6, and then back to 2. All right, so again, easy concept. All you're doing is literally connecting the dots. The biggest challenge is making sure that you know that you have a little bit of freedom here. There's a lot of different answers. So again, just because your answer is different than mine does not mean it's necessarily wrong. It just could be different. All right, that's it. Thank you for watching. Have a good day.